All right, this is our final project presentation in CSCE 413. All right, so our project was to create a flashcard study helper. We wanted to make this for students where they could create, study, and store their flashcard sets. So we wanted students to be able to create their own flashcard sets and then like have the database maintain the relationships between the students who created them, who's using them, the flashcard sets, and etc. So the database, we wanted it to track the study activity, and we wanted to also classify the users into activity levels based on several different usage metrics that we'll get into. All right, so here is our entity relationship diagram. The main tables to focus on are kind of these ones up here. So you've got the user, which is the person using them, and then they can belong to a class. They can start their own user sessions. You can see this is where we're tracking some of those usage metrics, like the total cards that they've turned and studied, the date that they've accessed it, the deck that they've been using, and the user ID that the user session belongs to. And here the user can create flashcards, create flashcard decks, where here with the flashcard, it's got the front text, which is like the question, back text, which would probably be the answer, as well as like the user ID that created that. And then as well with the flashcard deck, it's got the name, which would be that subject label, the ID of the flashcard deck, and some of the flashcards that are in it. So then here there's a belongs to many relationship that would show all the flashcards that belong to which decks. And then here is some embeddings that belong to each of the flashcards that label it into different labels. All right, and then here's a lot of what you saw earlier in the entity relationship diagram with all the different tables and their attributes. But here, I wanted to point out the many-to-many relationship and how that's established in MLPQ with the deck info table.
So when it comes to our data, we needed lots of flashcards. And so we first brainstormed some labels, which were in the form of subjects. So things like math, economics, history, etc. And then for each of these labels, we queried ChatGPT to create a few dozen examples of questions and answers that we then used for our data set. Beyond this, we used an open source text embedding model, Albany LM L6P2, to convert these flashcards into high dimensional vector embeddings, capturing all of the semantic information. And then we were able to convert these vectors into MLPQ compatible text files. And this leads us into our first function. We implemented a SVM classifier to provide single and multi-label classification of our note cards. And so here on the right, you can see a low-dimensional UMAP projection of all of our sentence embeddings for the whole data set. And we can see the clustering by color here, as well as some overlap between the clusters, which we found to be very interesting and is why we think that the multi-labeling is a very useful feature to have. And so the way that it works, we essentially take the flashcard text, both the front and the back, and we create the high dimensional vector embedding via our open sentence embedding. And then for the sake of our purposes, we used a dimension reduced version of this vector, which we converted to 4 dimensions with principal component analysis. And then these reduced embeddings we used to train a SVM via scikit-learn. And through scikit-learn, we can extract the coefficients and intercepts as attributes, and we can translate them into the SVM file that we can see on the bottom right here. And so this gets us into some classification examples. For this example, we did multi-label classification. So we have a few queries here, just getting like the card ID and the title name. And so, for instance, card 58 here relates to cloud computing and the delivery of services. And our labeling suggests computer science as well as economics. And so for most of these, we can see that they are very reasonable labelings for these cards.
So moving on to our second function, we really what we wanted to do is just be able to calculate aggregate statistics for the users. So as we saw in the ER diagram, users can create cards, they can create decks, as well as they can use them for their own studying. And so we wanted to be able to aggregate those statistics across all users. And so the left one on left query here is an aggregation query in MLPQ to see how many cards each user has created. The middle one here is to see how many cards each person has used, as well as the right one over here is to see how many decks each user has created. And then here are the results on our sample data. And so we see that the name of the user ID, as well as the number of cards created, number of cards used, as well as the number of decks created. And this transitions into our third function, which we wanted to be able to take and use this aggregate data to be able to classify the users into high, medium, and low activity. And this is based off of 4 criteria. Basically, for each one of these layers in the decision tree. Topmost layer is seeing just when the account was created, how long the user has existed in the system. The second layer is how many cards the user has used. The third layer discusses how many cards a user has created. And then finally, how many decks a user has created. And so we want to be able to classify each user based off of how many of these criteria that they satisfy. And those can be seen within the nodes here of this tree and where each path leads them to which classification. And this is how we implement it in MLPQ. So we see each line represents a specific label, but as well as which conditions they needed to satisfy in order to get that label. And so we can notice, of course, that for all low, medium, and high, there are multiple paths within our decision tree that can lead to a specific labeling. And so all of these entries reflect each of those paths. And this is an example of how we implement it in MLPQ. So we use the aggregate queries that we used in function 2 here, along with the decision tree in order to output the classifications for all the users. So for our sample data, we had 6 users, and then here are those classifications. That's it. And so for future work, as we discussed earlier, we reduced the dimensionality of the embeddings. For future work, we want to increase that, maybe not all the way to 384, but just increase it from 4. Also, we want to include some way of semantic clustering / search based off of the note cards regardless of the label, as well as we want to refine the decision parameters for our decision tree. Here are some of the citations, and thank you.
Thank you very much.
Thank you.